Hello folks, welcome back to our long series of lectures from the course Learn Cybersecurity with Python. I hope you all liked the previous lectures where we learned how to set up a host-only network on VMware and install the legacy Python 2 on Parrot OS with Docker. Today we learn about sockets. What you see on the screen right now is a TCP socket. In order to understand it, let's break it down step by step. As you can see this rectangle over here, it is a TCP socket with parameters AF underscore INET and SOC underscore stream. AF underscore INET says that we are going to use a standard IPv4 address for this socket, while SOC underscore stream states that this will be a TCP client. Now when this socket is initialized as an object, it becomes a client, which you see over here, which we use later to connect to the target host and target port mentioned over here. Let's try to understand this better by creating a WebSocket TCP client and server in Python. To start creating the server, let's quickly import the socket module and define the host and the port variables. This is a standard loopback interface, that is localhost that we have defined as host. And for port, we can take any of the unprivileged ports. So let's take it as 65432. Now using with, we'll use socket.socket and the parameters that we discussed, AF underscore INET and SOC underscore stream. As S, which we'll use as an object to perform the socket functions. Now we'll bind the socket to the host and the port, for which we'll use s.bind host and port as arguments, and then we'll set up the socket to listen for connections. Finally, we'll set up the socket to accept the connections and pass the results in connection and address in the form of a tuple. Now using with again, as long as connection is established, we'll print connected by address, which will have the host and the port of the client. Now while this is true, we'll set up the variable data to receive the connection response. And if no data is coming, we'll break the connection. Finally, we'll use the send all function to send all data from the connection as long as the while situation is true. And in this way, our TCP socket based server is ready. Now, since our TCP server is created, let's quickly create the TCP client. In order to create the client, we'll still need to import the socket module and define the same host and the port that we defined in the TCP server. Again using with socket.socket to create a socket object and passing the AF underscore inet and sock underscore stream arguments. We'll use a socket object to connect to the host and the port. Once the connection has been made to the socket object, we'll use it to send some data to the server in the form of byte stream. So we'll write B in colon the data that we want to send in the form of byte stream. And lastly, define a data variable which will receive the data from the server. In order for some clarity, let's print out that data as well. Now since both of our socket based client and server are ready, let's put them to use. To do this, open a terminal and move to the location where you have saved these files. Let's run the server first. It seems hung because it is waiting for connections. Let's open a new tab and run the client. As you can see, in the server a connection has been received from localhost port 54928 and the client has received the byte stream hello world. Now to check if your socket is running, you can also use the netstat command. For that, let's type netstat -an grep TCP. Why grep TCP? Because when we run this command, it will give us all the sockets that are system level as well as on the network, and we only want to filter for the TCP socket that we have run previously. As you can see, our TCP socket running on localhost port 65432 is showing with netstat -an. While you can also use the lsoff -i -n command to list the open internet sockets with the program, PID and user running them.